Yeah, so I want to talk to you today about performance, specifically performance within the context of serverless apps. My name has already been said, is Marco. I'm originally from Italy, but I am based here in Belfast, where I've lived for quite some time now. I'm the CTO at Trilo, which is a fintech startup, and other things as well. Particularly, I write for the Serverless Mindset newsletter, which if you're not subscribed already, feel free to go ahead if serverless is something that interests you, which I suspect it is. So, okay, so performance. What I want to talk to you about is, first of all, I want to just spend a few words on why performance. What is it that matters about performance? Why are we even bothering? And then I'll dive into 4 strategies that we have found to be especially useful and helpful when it comes to improving the performance of our serverless platform. Your mileage may vary. You may find that not all of these strategies apply to you. Maybe, perhaps, hopefully, at least some of them do. But the key point I want to drive home is just to get us all thinking just a little bit more about performance. It was mentioned earlier that I believe Werner Vogels, CTO of Amazon, has kind of declared that this is not the year of performance with the Frugal Architect initiative and all that. That resonates, that makes sense. We are, I think, at a point with sort of the state of kind of the web and also applications in general where there is the possibility now to go above and beyond when it comes to performance, and we can leverage certain strategies that, and some of them apply especially well within the context of serverless, to make our apps and our software not just average fast, but also above and beyond fast, something that truly delights our customers and our users. Okay, so a few words on performance. As I said, why should we care about it? Is performance just about speed? Can we just use speed and performance as synonymous, or is it maybe not a little bit more nuanced than that? And how much effort should we put into it? Just all well and good. Okay, maybe performance is useful, is helpful, but just should we spend the next week, 2 month? How long should we just how much effort should we put into performance? I love this quote. It's from the Mozilla Developer Network, MDN. Good performance is an asset. Bad performance is a liability. And I would probably add, average performance drives you to irrelevance, makes you just look like just everybody else. And so performance is something that matters. And so you can have bad performance and then have a liability, essentially have people leaving your service because they can't stand the fact that you're too slow. Or you can use it as an asset. You can just marvel people at just how quickly things are happening within their as part of their experience with your software. A quick Google search will give you these things. Why is performance important? You want to improve your bounce rates, you want to improve your conversion, you want to drive up your revenue, you want to make your users happier. All of those are good reasons why performance matters. Conversely, of course, people are more likely to abandon your website or your application and are obviously going to have a terrible experience, especially the slower your application gets. But most important of all, performance is noticeable. And here's the thing. Here's where performance differs from something like, for example, security. Okay, security is something that you should absolutely care about, obviously. And depending on also maybe on what industry you're working in, maybe you're in a highly regulated industry like we are with being in fintech, of course, security has to be at the center of what you do. But at the same time, security is one of those things where you just have to do it because you know it's right, and because maybe the government will chase after you if you don't. But you just have to do it because it's right. It's not as though if you spend the next 3 weeks, for example, improving your security posture, people will notice. Until and unless, of course, there is a data leak or something, and then obviously then you'll be grateful that you did invest the time in it. But the point is, it's just not something that directly, immediately, you get kind of that feedback back from the people using your software. But performance is. And so if it's bad, people will notice and will complain. If it's average, as I said, it's kind of irrelevant. People expect things to sort of work at a reasonable speed. But if it's above and beyond fast, now that's when people, all other things being equal, so assuming that your service, the thing you're providing actually has some value, so it's not just fast for the sake of being fast, but assuming all of that, your software being faster than the average is an asset, is something that will drive people back onto your, will make people return to your service. So what is performance then? Is it just raw speed? Is it just a matter of, let's go hammer down, try and shave off as many milliseconds off our compute layer? Is it just a case of, if you make it faster, then that's speed, that's performance? Or is performance something a little bit broader? And I'm going to argue that performance is not just raw speed. It's not just about, let's say, the configuration, the memory configuration that you have on your Lambda, where you try and make it a little bit faster by adding some memory. Performance is about, it's that obviously, but it's also, in big part, is offering a feeling of progress. In other words, making it look to the user as though things are moving along, things are happening quickly. This thing is dynamic, things are happening. And so there's this sort of concept that I've been sort of been talking about for a while, which is the difference between speed and the appearance of speed. And so whereas speed, as I said, is you go and hammer down your resources and find out ways to shave off milliseconds, appearance of speed is all things being left untouched. And so you're not necessarily making any specific process any faster, but you can reorganize your experience in a way that it looks as though things are moving along and they're moving along nicely and fast. And people get that kind of nice feedback loop as they use your software. It's basically, it's showing some content to the end user as quickly as possible. Okay, that's kind of the idea. Some examples, more or less controversial depending on where you stand, but it's, for example, what does it look like to remove unnecessary loading spinners? What if instead of having a loading spinner, you just okay, sure, maybe you're waiting for some content to come back from your backend, but is there something that you could show before, as you wait for whatever it is that you're waiting coming back from, say, your database, right? Is there something that you could show and then gracefully, once the extra information comes in, integrate that into your view already? There are techniques, there are ways to do this, but it's just something that I want to sort of start thinking about, as opposed to just having a loading spinner, waiting until all the data has come back and then displaying that sort of piece of information. Similarly, I've been arguing for the need to either avoid or reconsider at least server-side rendering. I think that within the context of serverless, it doesn't make as much sense as it does sort of outside of the world of serverless, and that is because there's more latency. Generally speaking, sure, there's ways to mitigate things like cold starts and things like that, but just when you do serverless, you have to take into account that there is a little bit of extra latency. If you're honest about it, you know that even cold starts, you're never going to get completely rid of them, even with all the best intentions. And so, just don't do server-side rendering is basically been my proposition. And so, how much effort should go into performance? All of what we've said is maybe well and good. Maybe you agree, hopefully. But just, okay, given all of that, should I then go and spend, in the next few weeks thinking exclusively about performance? Well, I don't have you have the answer to that, obviously. But the point is that it depends on, obviously, what you're building and for whom. Okay, so it's the amount, how much effort you should put into performance is proportionate to what it is that you're building and for whom. But it rarely, if ever, makes sense to build something that's slow. Okay, even if you're building something that's completely niche and it's just maybe internal or whatever, anything you can do to give people some time back from their day, rather than being there waiting for your infinite, loading spinners delivering data. Well, anything you can do, that is great. That is something that we should do. And so, the answer to just how much effort should go into it, I don't have the exact number. I can't tell you that. You're gonna have to find that answer. But The more generic answer is that, yeah, probably more effort than you and I are currently putting into it. So with that, I'm going to dive into now 4 strategies that we have found really helpful. Again, some of these you may find that are maybe somewhat obvious, others maybe you haven't heard before. Hopefully, at least some of these strategies apply for you, but if they don't, at least I want to get you, as I said, to think about performance in a way where you don't settle for just the average, just something that's normal fast. You know, what can you do to have leverage performance as an asset, as something that makes people love and delight and return to your app or your application or your piece of software? So strategy number 1 is resource optimization. The idea is very simple here, okay? Basically, look at your architecture, look at the resources that you're using, narrow it down to what services are being deployed, okay? And then for every service, look up what it is that the best practices for optimization are when it comes to each and every one of those services. This is, in some cases, relatively easy. So for example, you can see here on the slide, if you go and look up something like Lambda performance optimization best practices, you'll find not only the documentation, the docs, which are good, but you'll find also a bunch of really well-written blog posts like this one, where basically it's all just laid out for you. You just follow the instructions and you'll get there. Obviously, it takes some work, but it's fairly easy. Other services within or without AWS, maybe you'll still find it within the docs, but maybe there's not as much. It's not as easy to find. You have to dig a little bit deeper. Other services, for example, like with Dynamo, if you Google it, you know, Dynamo performance best practices or something like that, it's pretty much everyone's going to agree. It drives down. It comes down. The bottom line is one thing, and it's you need to improve your data modeling. And the gold standard, if you want to absolute top performance, is going to be something like single table design. So the answer is going to be there, super clear, super quick to find. Implementing that is quite hard. For any of you who has done single table design, you would probably know what I'm talking about. It's quite hard to get there, and so that's one scenario where it's super easy to find the information. It's not a mystery, but doing it is hard, and so then you have to judge whether that's something that matters for you or not. If you were like me and you love AppSync, we've been having a lot of fun replacing basically a lot of our Lambda kind of custom code with JavaScript resolvers powered by AppSync. The idea there is basically getting rid of as much custom Lambda executed code and replacing it with what is essentially a direct integration. So that applies to AppSync, but it also applies to other services like step functions and things like that. So wherever you can remove Lambdas and use direct integrations, that's also another way of optimizing your resources. So this is the idea: resource optimization. Understand what services are in use within your architecture, and then go down each and every service and implement the best practices that are recommended. Not particularly uncontroversial, but it can be hard to do it. Strategy number 2 that we have found very helpful is event-driven architecture. Now, I don't know that event-driven architecture comes up that often within the context of performance necessarily. And obviously, there's loads of benefits with event-driven architecture. But when it comes down, if I want to just narrow it down to why it's helpful with performance, is that it helps with the appearance of speed, which we referred to a moment ago. So it works like this, okay? With an event-driven architecture, you are able to turn what are perhaps currently synchronous processes into asynchronous processes. What that means is that perhaps that process remains just as slow, okay? But if you're able to remove it from sort of the user's experience, in other words, you run it in the background as an asynchronous process, and you don't make the user wait until a response comes back, well, then all of a sudden, you've not done anything in terms of speed. The raw speed is perhaps still quite slow, or whatever it is, but the appearance of speed all of a sudden has taken a massive boost. all of a sudden, for all intents and purposes, for the user, it looks like this is fast because he gets an immediate response, notwithstanding the fact that there's stuff running in the background, okay? So an asynchronous process can be slow if the user doesn't have to wait for its response. That's sort of the idea there. When can you make something asynchronous? Again, up to you. You have to figure it out using event-driven techniques. But ideally, yeah, when the user doesn't need to wait for the response, when the process has a high probability of success. So say, for example, you have your settings page on your website, and there's an area where people can go and update their profile settings. So they can go there and change their picture and change their name and a couple of personal information. Because you have good observability, you know that pretty much always works. There's like a tiny sort of a potential error rate. So what you do is you just tell, as the user clicks the save button, you just tell them, yeah, that worked, even though you don't know yet, because it's going to take an extra second to process. You tell them that it worked, because it 99.9% of the time does. And then you just have to figure out how to gracefully, and in the 0.1% scenario where it doesn't work, you have to figure out a way to gracefully inform the user later on, sorry, we just told you it worked, but there was a problem. There's ways to do that. It's not particularly controversial. It's not bad. But what you do is that you absolutely delight the 99.9% of users who, for whom this is working, and you just give that appearance of speed. Okay. Strategy number 3 is microservices. This one's going to be quick. Super simple. The idea is with microservices, you have more granular control over each and every one of your services. And so if you build your application using microservices, you are able to then identify areas where you want an extra boost in terms of speed, and you can allocate more or better resources to that particular microservice without having to do a complete review of your platform. And so that's where the other strategies interlock sort of well with this strategy, because then you can do resource optimization. You can do something like single table design, for example, with Dynamo, which is quite hard. But you can perhaps only do it for microservice number 1 there, which is the one that really matters and is the one that's being hit the most. Maybe perhaps for all the others, you just keep going with not especially optimized tables because it's fine. So with microservices, you have that choice, and you have the ability to optimize just exactly what it is that you want to give an extra boost in terms of speed. And then the last strategy that I want to talk about, this is the one I suspect that probably most people have not either not heard, or if they've heard of, they've not really considered it for their sort of use case, and it's the idea of local storage. Again, super simple, not anything that probably people haven't sort of done in other contexts, especially within the context of maybe native apps. But in the web especially, that's not very, very used. The pioneers of this, or the people that have sort of brought this back to a lot of people's attention, including mine, are the guys at Linear. Linear is this project management tool. Some of you probably know it. There's nothing special about Linear. It does what every other project management tool does. It does the tickets. It does timelines. It does, you assign tickets to people. Super simple. But when you use Linear, if you use it, immediately you realize this is unsettling fast. This is so fast. And the first couple of times you're like, oh, so maybe it's because, I don't know, maybe it's because my Wi-Fi today is especially strong. And then you keep going, it's like, this is really strong. And then you're away hotspotting or something, this is still fast. It's like, how do they do that? And it turns out they've sort of invented this idea, they call it the sync engine. And it's nothing other than a very, very well-built local cache, okay? They cache virtually all of your data, at least the one, I believe what is not sensitive, as I understand it, they cache it within the browser. And so as a result, you using this from your browser, it feels like using a native app, which is just incredible. So to do this, again, these are old and trusted technologies. You can use something like IndexedDB, or there's a cool service called Replicache as well that some people have been using. Nothing revolutionary about this, nothing new, but just something that most people, I think, haven't considered. And in the web, in the world of the web, we've kind of forgotten about it. Again, what you can do here is, instead of what they've done and building the whole thing like that, you don't have to do it. What we've done, for example, is we've identified areas, either areas that we weren't super happy with the performance of, that we were maybe getting some complaints about certain parts of our system that were a little bit slow, or even just areas that we thought within our system that we could really give it a boost because it's maybe a central part of our system. And we've started storing some of that data into IndexedDB. So then all of a sudden, people go into this kind of some of the most important parts of their Trilo dashboard, for example, and data is being returned to them immediately. Obviously, the downside of an approach like this is the very first load is still slow, right? But then as soon as you cache your data, the second and third and fourth time and so on and so forth is super, super fast. So you mix this with event-driven architecture, with microservices that allow you to apply these optimization to just the services that you need, and then resource optimizations for the resources that you care about and that you use in your architecture, and you end up with something that is above average fast. You get the kind of experience that, for example, Linear has with their tool. So resource optimization, event-driven architecture, microservices, and local storage are the strategies that we've been deploying successfully to improve the performance of our applications. And I hope you will find at least some of these useful, and that you will consider as you go back tomorrow, should I spend maybe a couple of days thinking about performance? I think you should. And I, for one, will definitely enjoy faster experiences being delivered out there, especially within the world of serverless, where I feel like for a while we've had a bad name because of cold starts and things like that. And so what can we do to close that gap? Thank you so much. And feel free to reach out to me on any of the socials or subscribe to the newsletter. Thank you.